My name is George Hammond. These are my teammates Justin Dye, Salman Gargazlu, Eric Hill, and Neil Mustafa. And our project is to design a cloud-hosted intelligent sprinkler system. The premise of our system is pretty simple. A normal basic sprinkler system installed in a house is pretty simple in its operation. You can set a timer and its schedule from that timer and the sprinkler will run. We want to do something that's a little bit more advanced than that accounts for a little bit more in the environment. So to do that, we have our cloud-hosted intelligent sprinkler system that'll kind of beef up the functionality of an existing sprinkler system a homeowner might have. So the objective of this sprinkler system is to manage it completely autonomously without user interaction post-initial setup, of course, operate with the local web user interface that a user can access and set parameters and preferences, incorporate microcontrollers, moisture sensors, and power circuits to keep it running autonomously, be solar powered so that it can stay online, analyze weather data and make decisions accordingly so that it can take in information from the environment and use it to decide whether or not to run a sprinkler, allow the user to set schedules because sometimes the user has preferences over the system, and have profiles as well for that, and then communicate real-time data wirelessly so that a user can see what's going on outside. So to do this, our basic system diagram is here. Outside, we will have just any amount of CC1310 launch pads, depending on the size of someone's system, all running with passive moisture sensors and powered with lithium-ion batteries, charging circuit, and a solar panel to keep it running online. These will communicate wirelessly through sub 1 gigahertz low-powered wireless communication. So that helps to last a long time. These will be on a timer to transmit data only periodically so that they can keep running. All the way to our sprinkler hub, which is going to be just another launch pad except with Wi-Fi capabilities as well, connected to a cloud-hosted service which will have that user interface, allow them to set the parameters, see the real-time system data, and this interface also communicates with the AccuWeather API to get real-time system data for the user's location so they can use the current weather and future weather conditions to make decisions on whether to run the sprinkler system as well. Our system is going to be designed to integrate directly with old solenoid taps, so whatever a timer is connected to now, our system will be able to connect to then, which will connect to any existing sprinkler system, and then based on that, be able to run it simply using all that data.
That looks like a lot of, I don't know, if it's really needed, I mean, if there is a rain gauge, right? There is actual rain, then the system, the sprinkler need not work. But in this case, you need to have a solar-powered, battery-powered, cloud hosting solution, and relying on weather data, which is not always accurate, right?
But for the current conditions, they usually are.
So if something that says like 70% chance of rain right now, so
yeah,
it could be rain or may not be.
Yeah.
So does this rely on, like, again, something very similar to a rain gauge that people use at home right now?
It relies on the moisture sensor for the environment data, so that's what our decision tree is for. We go through these decisions in order of importance to make a decision on whether to run the system or not.
Yeah.
So if you go ahead.
No, I was just looking at like the cost-benefit analysis of it, like what the cost of implementing such a system versus the benefit of, you know, if it rains, your sprinklers don't turn on, right? Other than that, is there any other benefit to this?
It's about the user preferences and what they can set depending on what they want for their system as well. So if they want, say, an area of like their yard to only be like 50% moisture capacity, they can do that.
So and that's a good selling point. You got a low spot in your yard that gets wet, and you got high spots up the hill that don't. My question was, there's a lot of hardware on this. Is there something that you can do a built-in check to say that sensor's out and not working? Because that's what I didn't get out of it. Was a good concept, but how do you know when something isn't working properly?
So we kind of have like cyclic checks to account for that. So say, since it's operated over a network, if we're not receiving data for a certain area, we can basically assume that something is given out at that point.
Okay, so you could run an individual check.
Yeah.
Okay.
Data updates periodically as the system's online.
Are you planning on directly driving the solenoid box? I don't see anything in between this, a launch pad there and the solenoid box. there's a missing box on this diagram that keeps you from blowing up your MCU.
The hub itself?
No, the solenoid, if you try that, you can't drive solenoids or anything else that has inductive spikes directly from an MCU. So there's nothing in here in between the sensitive electronics and more, so we say, industrial electronics that have nastier electrical qualities.
So there needs to be some portion of
Yeah,
power
that's
control
a key
between that.
piece in anything like this.
Yeah.
Another thing, back to the point of how do you know it's working, is that in the immediate aftermath of turning on the solenoids, your capacitors, moisture sensors ought to be registering something, and that would be a mechanism for that you need to look into in terms of the software to see that you're actually operating the way you think you are.
All right.